So we have that arc TS is 120, and arc TR is 100, and arc RQ is 30, and we have that PV is a tangent, which means point T is a tangent point of tangency. So here we go. Let's find them in order. We got angle VTS. So angle VTS, well, that's on the circle. So that means that VTS is going to be 1/2 of the 120. So that's a 60-degree angle. Angle TOS, Now we haven't done one of these for a while. TOS is coming from the center of the circle. That means it's a central angle. It is intercepting this 120-degree arc. So angle TOS is simply going to be 120. It's going to match that central angle. So that's TOS. And we can put these on here as we go. So this is 120. And we said that VTS was 60. Now let's find angle TNS. So TNS. Now that angle's inside the circle, so we need to look at the vertical angles for TNS and RNQ. Because it's inside the circle, we need to look at the intercepted arcs, which would be this 30-degree arc and this 120-degree arc. So since this is inside the circle, I'm going to take those two arcs and add them together. So it's going to be the 120 degrees plus the 30 degrees divided by 2, which ends up giving me 150 divided by 2, which is a 75-degree angle. Again, let's clear this up a little bit. We don't want to be looking at that. But we did figure out that this is a 75-degree angle. So it's always good to put what you know on the picture because it might help you find something later. Angle STQ. So angle STQ. Well, angle STQ has an intercepted arc of SQ. And we haven't figured out what that is yet. So we should probably figure out what SQ is because we know that since this is on the circle, this angle is going to be exactly half of that intercepted arc. So I've got 3 out of the 4 pieces. I've got 120, I've got 100, and I've got 30, which is a total of 250 degrees. That means this arc down here, SQ, is 110 degrees. If that's 110, that means the angle STQ is that 110 divided by 2. It's half because it's an inscribed angle, which means that angle is 55. Let's clear that up. And now let's figure out what our last 2 angles are. PTQ, going from PTQ. Again, this angle is on the circle, but it's intercepting 2 pieces. It's intercepting the 100 degrees and the 30. So it's intercepting a total of 150 degrees. So since that's 150 degrees, that means my angle is going to be half of that 150. So it's going to be the 150-degree arc divided by 2. That's a 75-degree angle. And last but not least, we have angle TNR. So angle TNR. Again, this is a chord angle. So I could do this by adding up the sum of the intercepted arc which is 100, and the intercepted arc of its vertical angle, which would be 110. But I don't really want to. What I notice is that I have a 75-degree angle right here, and that's a linear pair with the angle that I'm looking at. So that means it's got to add up to 180, so that's 105 degrees. All right, flipping a couple pages, we get to these two examples that I did not do when we were talking about the angles that were outside. So again, we just need to look at these theorems and figure out which theorem is going to work for our situation. On this example over here at the left, if I'm looking for x, that angle is inside the circle, which means I have to trace out its vertical angle as well, and I have to find those intercepted arcs. So x is intercepting 110, and its vertical angle is intercepting 50. So this is a pretty straightforward. It's going to be the intercepted arc of 110 plus the vertical angle's intercepted arc of 50 divided by 2, which ends up equaling 160 divided by 2, which means this is going to be an 80-degree angle. Next example. On the next example, we're looking for the measure of angle P. So angle P is this angle that comes through the circle. It's outside the circle, so that means I'm going to take half the difference of the two intercepted arcs. Well, the intercepted arcs would be this small arc RT and this big arc of 100. So it says QR and ST is congruent, because as I look at this, I didn't see how I was going to do this, because I don't know what this arc is, and I don't know what this arc is. And if I don't know that arc, I won't be able to subtract. But right now I know that it should be 100 minus that arc of x divided by 2 will equal my angle P. So I've got some work to do in finding this missing arc. So this is why this QR to ST is important. If QR and ST are congruent, if the chords match, the arcs match. Or in other words, if you have two chords that are congruent, they're going to cut off congruent pieces of the circle. So this over here is also 95 degrees. So now I have 3 out of the 4. I can find that missing piece of x and continue on to find angle P. So I have 95 plus 95 plus 100, which gives me a total of 290 degrees. That's only going to leave me 70 degrees for x. So if x is 70, I'm going to come down here, I'm going to get rid of x, and I'm going to replace it with 70 degrees, and now I can figure out what angle P is, because 100 degrees minus 70 is 30, divided by 2 means that this is equal to a 15-degree angle outside that circle. More examples. I know you're excited. On the next example, I'm looking for x, which is the big arc of the circle. So what I notice is I have a tangent-tangent angle. It looks like I can't do anything, but I remember that a tangent-tangent angle is always supplementary to its smaller intercepted arc. So if this is 45, this has to be a 135-degree arc, because that would be supplementary. If I only have 360 degrees in the whole circle, 360 degrees minus that 135 is going to be 225 degrees for x. So it's faster than you think. Next example. I'm looking for the measure of angle ABC. So A to B to C. It's on the circle, so I know right away it's going to be half of this intercepted arc. It tells me that angle AOC is 80. So this angle here in the middle is 80 degrees. But I know that that central angle will match the intercepted arc. So now I figured out that that arc is 80, and I know that an inscribed angle is always half of its intercepted arc, so angle ABC must be 40. Next example. I'm looking for x, which is this arc. I see that I have an angle outside the circle that measures 20. That angle should be a combination of these two arcs that it cut off. So the theorem says that the angle 20 degrees should be equal to the big arc minus the smaller arc, which we have is x, divided by 2. So I got a little bit of algebra to do here. I'm going to multiply both sides by 2. I end up getting 40 is equal to 100 minus x, and I know that 100 minus 60 is going to give me 40. So x has to be 60. On the next example, I notice that I have an angle inside the circle. So instead of subtracting, I should be adding. So again, I like to trace this out. If this is a 100-degree angle, it is intercepting this arc of x. But I also have to trace out the vertical angle that's being cut. So this angle cuts off 110. So the theorem here says the 110-degree arc plus the other arc being cut off, which is x, divided by 2 should equal our 100-degree angle that we started with. So again, a little bit of algebra, multiplying by 2, I get 200 equals 110 plus x, and I know that 90 plus x, 110, is going to give me 200, so that arc must be 90 degrees. This next example you want to mark down as a test example, because I know for a fact this one I put on the test. It looks very complicated, but it deals with triangles and circles and triangles inside of circles. The main thing to remember here is that you have a lot of tangent angles. So while it may seem impossible to solve at first, if this angle is 60 degrees, I know that this arc, this smaller arc right next to it, is 120 degrees, because a tangent angle should add up to 180 degrees with the intercepted arc. Well, I'm going to do that for the other angle over here as well, 50. If that's a 50-degree angle, its smaller intercepted arc has to be 130, because those two have to add up to 180 degrees. And now at the top, I don't know what angle A is, but I can figure it out, because I had a 60-degree angle, a 50-degree angle, and I know that angle A plus those two should equal 180 for the entire triangle. So I know that angle A has to be 70 degrees. So if this angle is 70 degrees, still using the circle theorem now, the part of the circle has to add up with that tangent angle to make 180. So that's a 110-degree arc. Now that I have all those numbers on my circle, I can go about finding everything else inside the circle. Because let's trace these out. Angle R is intercepting that 120 degrees. So angle R has to be half of that, which is 60. And if I get rid of that traced out angle, and I trace a different angle, I'm looking at angle Q. Angle Q cuts off this 130-degree arc. So angle Q has to be half of 130, which is 65. And then last but not least, if I trace out angle S, we will see that angle S is cutting off the 110-degree arc. So angle S has to equal half of the 110, or 55 degrees. So now I found all those angles of the triangles and all the pieces of the circle using nothing but tangent-tangent angles and inscribed angles. So now let's just go back and make sure we got all of them right. Angle A would be 70. Arc RS we figured out was 130. Arc QR was 110. Arc QS was 120. Angle RQS was 65. Angle QRS was 60. And angle RSQ was 55. And if you check your numbers, you'll notice that all three arcs add up to 360 when combined, and all three angles of both triangles add up to 180 degrees, which means I have to be correct because everything fits.